Algebra 2, set 20, simplification of radicals and a line parallel to a given line. Okay, so with radicals or square roots, we can say that the square root of 10 is the same as the square root of 2 times the square root of 5. To show that this is true, you can use a calculator, and if you use a calculator, you find that the square root of 10 is 3.1622776. And we can find that the square root of 2 is 1.4142136, approximately, and the square root of 5 is 2.236068. So if we take the 2 on the right and we multiply them, what we end up with is 3.1622777. So we're off by a tiny little amount, and for our purposes, we can say that those two values are equal. So we have a theorem. The product of square roots theorem says that if you have m and n and they are non-negative real numbers, then the square root of m times the square root of n is equal to the square root of mn, and the square root of mn equals the square root of m times the square root of n. So what that really means is if I have the square root of 2 times 5 times 5, that is the same thing as the square root of 2 times the square root of 5 times the square root of 5. Which makes this really easy to break it down in further problems. We'll do another example. The square root of 3 times the square root of 3 times 3 times 3 times 5 is the same as the square root of 3 times the square root of 3 times the square root of 3 times the square root of 5. So we'll do an example. Simplify 3 square roots of 50 minus 5 square roots of 200. So the easiest way to solve these square root problems is to break it down into factors. So the simplified factors of 50 breaks down into 5 times 5 times 2. So 200 breaks down into 2 times 2 times 2 times 5 times 5. From here, we look for pairs, because pairs of square roots are going to cancel each other out. So, in other words, if I have square root of 5 times the square root of 5, that's going to break it out, and we will end up with 5, because the square root of 5 times the square root of 5 is the square root of 25. Square root of 25 is 5. Moving on, minus 5 square roots of 2 times 2 times 2 times 5 times 5 is going to be the square root of 2 times the square root of 2 times the square root of 2 times the square root of 5 times the square root of 5. So now we look for pairs. So we find that these two pairs give us 5, and we've got a pair of 2's here, so we can break out a 2 and break out a 5. So we can say on the left 3 times 5 times the square root of 2. So 3 times 5 times the square root of 2. And on the right, we have 5 times 2 times 5 times the square root of 2. 3 times 5 is 15, and that's square roots of 2. And 5 times 2 times 5 is 50, so minus 50 square roots of 2. So 15 square roots of 2 minus 50 square roots of 2. If you remember, with square roots, you can only simplify if they have the same square root, which these do. So it's almost the same as saying 15x minus 50x gives us negative 35 square roots of 2, because 15 minus 50 is negative 35. We'll do another example. Simplify 3 square roots of 2 times 4 square roots of 12 times 2 square roots of 3. What you really could do here is just multiply everything out. I'm going to break it down just a little bit just so that you can kind of see the rule. 3 square roots of 2 times 4 times the square root of 4 times the square root of 3 times 2 square roots of 3. The square root of 4 is 2, and so we have 3 square roots of 2. 4 times 2 is 8. 8 square roots of 3. And then we have 2 square roots of 3. We have 2 square roots of 3, so that breaks out a 3. So now we have 3 times 8 times 2 times 3. And then we're left with a square root of 2. So when we multiply 3 times 8 times 2 times 3, what we end up with is 144 square roots of 2. Okay, one more example. Simplify 4 square roots of 3 times 2 square roots of 3 minus square root of 6 in parentheses. So we're going to distribute 4 square roots of 3 times 2 square roots of 3 minus 4 square roots of 3 square roots of 6. And so whenever we have a pair, so square root of 3 times square root of 3 gives us 3. So we have 4 times 2 times 3, or in other words, 24 on the left. And then on the right, we have 6 is the square root of 3 times the square root of 2, which makes us a pair. So square root of 3 times square root of 3 is 3. 4 times 3 is 12, so we have minus 12 square roots of 2. 24 does not have a square root with it, and 12 does. We cannot simplify this any further, so the answer is 24 minus 12 square roots of 2. Okay, moving on to graphing. If I have the equation of a line, y equals 1/2 x plus 2, and I graph it, I know the y-intercept is at 2 and the slope is 1/2, so it's going to look like this. If I have y equals 1/2 x minus 1, the y-intercept becomes -1, the slope is still 1/2, so we go up 1 over 2. And then if I have the equation y equals 1/2 x minus 4, again the y-intercept is -4, the slope is 1/2, so I go up 1 over 2. So you'll notice in all three of the equations, they all have the same slope, but they have different y-intercepts. So whenever you have the same slope, you end up with parallel lines. Parallel lines always have equal slopes, and that's going to come into play with our equation, or with our problem here today. So it says find the equation of the line that is parallel to the line 2x, find the equation of the line that is parallel to the line 2y minus x equals 2 and passes through the point 3, -1. So the first piece of information is that we know it's parallel to this line. So we need to put this line in y equals mx plus b form. So we'll add x to both sides, so 2y equals x plus 2, and then we'll divide everything by 2. So y equals 1/2 x plus 1. We find that the slope then is 1/2 because y equals mx plus b, so the slope is 1/2, and it says it's parallel to that line. So parallel to that line means it has the same slope. So our new equation is going to say y equals 1/2 x plus b. What we need to find now is b, and in order to find b, we're going to use the point 3, -1. We have an x and a y, so we'll plug that in for x and y. We get -1 is equal to 1/2 times 3 plus b. So -1 equals 3/2 plus b. When I subtract 3/2 from both sides, I end up with -5/2 is equal to b. So now I have the slope of my new equation and I have the y-intercept of my new equation, so I can put them together. Y equals 1/2 x minus 5/2.